Plus is what happened? Plus is changed to dot. Zero is changed to one. Vice versa. Okay. For example, we have seen a function like f equal to ab. Then what will be the dual of this? A will become a bar. Dot becomes plus b bar. Okay. This is the dual of a function. There are certain functions which are self-dual. That means f dual again dual is equal to function itself. These functions are called as self-dual functions. Okay, self-dual. Okay, now coming to the next slide. Now we are going to see about the logic gates. Logic gates. All the chips which are built inside the computer or mobile phone are basically logic gates only. These are nanometer. Those are in nanometer length, which are embedded in a chip by using VLS and embedded systems. That is easy topic. Easy electronics and communication topic. Now let's go to the universal gates. What are the universal gates? Universal gates are AND, OR, and NOT. NOT is nothing but the inverter. Inverter. Now let's come to the what is the buffer gate? Buffer. Buffer gate implies if A is given, then it will simply give the A only. I mean, if A is 0, it will give 0. If A is 1, it will give 1. Okay. Next is the NOT gate. NOT is the inverter of buffer gate. Inverter means negative. I means reverse. Here, this symbol is this one. This is the NOT. Okay. If A is given, here A bar will become. So, for example, 1 is given, then 0 will come. 0 is given, 1 is come. Okay. That is the NOT gate. Universal gates are AND, OR, and NOT. Okay. Why they are called universal gates? Because those are the basic building blocks of the digital logic. I mean logic components. For example, these are NAND, NOR, XOR, everything can be written in using the AND, OR, and NOT gates. Okay. Some important questions are there. I will tell in the next lesson. Now let's go to the OR gate. OR gate. OR gate implies A plus B. Let's see the truth table. Truth table. A, B, A plus B. You need to remember this. Easy it one. 0, 0, 0, 1, 1, 0, 1, 1. 0 plus 0 is 0, 0 plus 1 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. 1 plus anything is 1. Okay? The what's this called? Yeah, the logic diagram. Yeah, this is A, this is B, this is A plus B. Okay. In this, for example, the enable input and disable input, let's take. Hmm? Enable. If we give 0, 0 here, 0 plus B is B. 0 plus B is B. So 0 is the enable. 0 is the enable input. 1 is the disable input. How I have found out, do you know? Here, consider it will not go down. Here, when we given 0, whatever the input is B, that will be the output. No, no, no. 1 minute. Yeah. OR gate enable. Yeah, let's now go to a AND gate. I will confirm it tomorrow. AND gate. This is the symbol of AND gate. A, B, A into B. Okay. A, B, A, B. 0, 0, 0, 1, 1, 0, 1, 1. This is multiplication now. 0 to 0, 0, 0 into 1, 0, 0 into 1 into 0, 0. 1 into 1 is 1. Okay. Mm, uh, Here the enable input is 1. When 1 is given, let us see what will happen when 1 is given as one of the input. Here 0. 1 into 0, 0. Now let to give 1. 1 into 1, 1. So when the input is 1, when one of the input is 1, we are getting the same input. Same input as the output. So this is called as the disable input. Disable input. No, 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 enable input. So let us consider the reverse case. When one of the input is 0 and other input is also 0, comma 1. 0 into 0, 0. 0 into 1, 0. Yeah, same output for every time. This is called as the disable input. I hope you are understood. I got confused. What is meant by disable input means same output for one input, whatever the other input may be. Here A, B, C, same output like 0, comma 1. That is the disable input. Okay, you can check in the OR gate. Uh, Now let's go to the inverter. Inverter implies NOT gate. NOT gate. It simply looks like this, but A and A bar, here 0, here 1, here 1, here 0. Okay, its structure will be like this. This is the bulb. Okay, this is the NOR gate. This is the systematic representation, symbolic representation by using bulb. This is the bulb. Okay, for OR and NOT gate, for OR gate, it will be like a series connection. No, no, no. For a AND gate, it will be like a series connection. AND gate A, B. Okay, because if simply if this is closed, circuit will not function now. Suppose this is the arrow mark, this is the arrow mark. When both are closed, both are closed means 1 and 1. Then only the circuit will be in operation. Okay. So this is the symbol. When 1 is open, like 1 and 0 will come. Suppose this is open, 0. This is closed, 1. What is the use? Circuit is not closed. Circuit will not function. So this is the symbolic representation of AND gate. For OR gate parallel. Anyone. This is the circuit. Okay. This is the A. This is the B. Okay. Consider A, B. Okay. If now A is closed, closed means 1. B is open, 0. From here to here the circuit will flow. Okay, but consider the direction like this. If this is 0 and this is 1, the current will flow like this. Don't think that I'm explaining current means logic 1 means 5 volts in basically. Logic 0 means 0 volts. That's it. There is no difference between logic 1 and logic 0. Okay. I think basic gates. Basic gates were completed. NAND has a universal gate. NAND gate. Let us see about the NAND gate. NAND gate. NAND gate means AND gate complement. AB whole bar. That is equal to A bar plus B bar. Okay, this is from De Morgan's law. Now let us see about the truth table. A, B, AB, and AB bar. Mhm. 0, 0, 0, 1, 1, 0, 1, 1. AB is multiplication. 0, 0, 0, 1. So here divide 1, 1, 1, 0. Okay. Okay. Now we need to implement so that NAND gate is a universal gate. By applying, by forming the AND or OR gates, AND or NOT gates using the NAND gates. Okay. For NOT gates. Here consider A into A. A here bar, A bar. Okay. Next is OR gate. We had A plus B. Consider two complements. A plus B whole bar. That is equal to A bar dot B bar whole bar. So we need to consider A bar. This one is A. Another one B. Here, here is B. Here A bar. Here B bar. A bar dot B bar whole bar. A bar dot B bar whole bar is equal to A plus B. और हो गया. Now we need to implement AND gate. AND gate using NAND gates. And AND is AB. One minute.